Logan. I'm the CEO and one of the co-founders of Kurtosis. And I'm not actually going to tell you what the next Black Swan event is going to be, but I am going to talk about the concept. And thank you all for staying for the very end. I'll try to make this a good summary of everything you've seen so far today, and also share a bit about the work that we've done. So, a Black Swan event, what do I mean by that? What I mean is an unknown unknown. If you spent your whole life seeing swans that are all white, and you go out swan watching, you're not going to be thinking to yourself, what color is the swan that I'm going to see? So if you were to see a black swan, and they do exist, it would be shocking to you. It would be something you never planned for, and that is what the next security exploit, the next big problem is going to feel like. So we don't know about security risks in Ethereum until they happen. And that's been a theme of a lot of the talks that happened today. We can do our best to try to catch them. We can do our audits, our fuzz testing, our bug bounties, public and private test nets before things go into mainnet. But at the end of the day, there's always going to be unknown unknowns, no matter how much work we put into the security and testing, but it doesn't mean we shouldn't do it. It's just the world that we live in. And one of the elements of this is complexity. So one of the first talks today, Danny Ryan talked about complexity. He said complexity, avoid complexity. Complexity is evil, I think is the phrasing he used. Complexity happens. It's a large part of the current architecture of Ethereum is a lot more complex than it used to be. We now have a good amount of client diversity, which is great for the ecosystem, but it also means we need to worry about interoperability between different software clients on the CL layer and the EL layer and between them, which gets me to the next form of complexity on the L1 is the separation of EL and CL layers. We also have the introduction of PBS as a standard and Flashbots infrastructure as a core necessity on mainnet. And don't get me started on all of the L2s that are popping up now, the shared sequencers you need to use those effectively, the data availability layers there, and we haven't even hit the smart contract layer yet, the application layer. So it's a lot of complexity. And the question is, with more complexity, we have more blind spots. How do we cover our blind spots? How do we reduce the number of unknown unknowns that we're dealing with? A couple of questions come to mind when we start to think about how to cover those blind spots. How do we build quickly without sacrificing security? Put otherwise, how do we build fast and not break things? How do we build with complexity while ensuring portability? By portability, I mean other people can actually run your software or sub-components of what mainnet or testnets look like in order to make sure that security guarantees and functionality guarantees actually work for their systems that use your components, your sequencers, your relayers, your nodes, your oracles, whatever it might be. And also, finally, how do we make sure that mainnet behavior stays the same when all of these different components underneath the user experience are all changing, upgrading, coming down, coming back up, and all that. When we first started working in the Ethereum ecosystem, the Ethereum Foundation was wondering the same. And our tool was really used quite a bit for the first time while testing the merge. And what the engineers on the Panda Ops team did was they used our tool to make reproducible local dev nets. And that, they used it a lot for testing the merge. They've done it for Chapella. They're doing it as well for the upcoming Dankun upgrade. And what it gives you is full node simulation in your test nets with client diversity, so you can test the interoperability. And really what I'm talking about is, yet another set of testing standards on top of the list of things that we've had before, which looks like complete end-to-end testing and chaos-style testing. Earlier, I think the second talk today was from Ben at Trail of Bits, who talked about using AttackNet, which used Kurtosis under the hood to do chaos-style testing in order to reproduce finality incident that happened on mainnet last year. That brings me to what is Kurtosis? What are we working on? It's a developer tool. It allows you to package up all the complex setup logic that goes behind spinning up nodes and services involved in a Web3 backend. And developers use these Kurtosis packages to spin up devnets and testnets that are customized in one-liners. And the top reasons people use Kurtosis for the sets of use cases I'm talking about here is one, it's very easy to configure your test nets and your dev nets with one-liners with a high-level JSON configuration. So rather than tracking down the environment variables, the command line arguments, different server processes, configuration file formats, none of that stuff, I'll show you what it looks like. It's a high-level specification, says what you want it to look like, and it just does it. You'll deploy with one line over Kubernetes or Docker. So for Docker, you're going to be debugging locally, or you're going to be doing rapid prototyping workflows. On Kubernetes, you're going to be doing it remotely, doing chaos mesh-style workflows like AttackNet from TrailerBits. And if you want to have a new testnet definition, you can use it's a dialect of Python. It's a very flexible and familiar language that prevents a lot of the mess of YAML charts you might get using other solutions to do this kind of thing. And that brings me to what are we doing specifically with the Ethereum ecosystem. The Ethereum package is this private DevNet in a box, deploy using one line. It's built for teams that need to do consensus layer testing and test validations of blocks across multiple client types and at multiple scales. Includes Genesis data, validator keys, node bootstrapping, and tools like a beacon chain explorer or transaction spammers or blob spammers out of the box. So a little bit of what that looks like. Promised you one line. It looks just like one line. You seen the picture? Yes, you are. Great. And once you run that, you get a bunch of services spit out. Whether you're running it remotely or locally, you have port mappings to your machine, so you can communicate with all the services using your favorite developer tools. You have a couple of different types of transaction and blob spammers that you can pick from, a fork monitor, Grafana and Prometheus for metrics, and you have a configurable and flexible set of EL and CL pairs. And the default example that I'm showing here is a lighthouse and a geth pair, but that's configurable. And the configuration looks something like this. This is a more advanced, it says JSON, this is the YAML. They're both compatible with what we're doing. But what you get is you can specify the pairs that you get. So this is a geth lighthouse pair. You get 2 instances of that. Nethermind and Teku pairing. A Bezu and a Prism pairing. You get 2 instances of that. And the full MEV infrastructure all running on your laptop or in a Kubernetes cluster of your choice. You can just grab it and you can go. So we had these DevNet tooling, but it's just a DevNet or a testnet. It doesn't actually get you all the way to the security guarantees that you want to have. And the reality is that it's our set of users and the experts in the different security areas that have talked today that can do that. It takes a whole village to get a reliable and secure Ethereum out for everyone. And trying to leave with some good vibes at the end of the day here. I personally believe Ethereum has the best village on this problem. This is a set of people that have contributed to the Ethereum package, this one line DevNet in a box. It's an open source project maintained by us and by a number of folks on the Ethereum Panda Ops team. And these are some folks that are using kurtosis and this package to improve security, improve reliability, and also to contribute back to the asset that everyone else is using across the community in order to do end-to-end reliability testing and chaos testing. And I ended early. Thank you.